So Taylor, you are correct. We're finding a limit now as x gets close to a finite value, so we're back to having to do left and right.
Okay.
Yep, two more. However, we are going to modify our thinking just a little bit as we get better and better with limits. So we're not going to do exactly what you did on the buff. Okay, there's a plan to this to try and get your brain thinking about limits in the right way. We go to this flashcard. Item 1 does not apply because x is not approaching infinity. So you go right to item 2. And you try to determine whether or not you can factor or not. The good news is this. I have never seen an AP question ever, since every question made public since 1969, that ever needed the quadratic formula. So most people do not Page toppings, points for page. I've also not seen a AP question that ever required any sort of complicated factoring. The factoring has always been the kind that when you learn factoring, it was pretty simple. They are not really trying to test you on factoring. They just want to make sure you know that that's something you sometimes have to do. So write on your paper the limit as x approaches -4 of f of x again. So normally we would find the left or the right. We're going to do a little shortcut here, so just stick with me. So we're not saying left or right, we're just saying overall, but we are in our heads we're thinking, hey, we got to check left and right. You have to check left and right. Next step, we're going to factor to see if we can divide. So we're going to find the limit as x approaches -4. The numerator does factor, and I'm only factoring in hopes that I can divide. So I'm hoping there's a factor in the numerator that is equal to x plus 4. And there is. Questions? Cool. So next line, I'm going to just write out my factors separately to make it a little more clear what's really happening. So we write equals the limit as x approaches -4. We're going to have an x minus 5 divided by 1 multiplied by, this time I do use parentheses, I just think it's a little easier to see what's happening. But I tend to go back and forth because either is fine. Any questions to that point about anything? Okay, don't cross this out. It will lead to mistakes. So don't do this. Don't do that for sure. Don't do this. Like don't cancel. Just leave it. But now you have to interpret it. So look up. Okay, the flashcard says we have to check left and right limits. So now you have to mentally think to yourself, the x that I'm going to plug in is not going to equal -4. The x that I'm plugging in is going to be very, very close to -4. It could be a little less or a little more because I'm checking left and right limits. Close to -4 minus 5 will always be close to what? Just say it. Try again. Close to -4 minus 5. Okay. Close to -4 minus 5 will be close to what? -9. Are you comfortable that it doesn't matter if I was a little more or a little less than -4, it's still going to be close to -9?
Yeah.
That's the variation here. With a piecewise function, you can't really do that because you're using a different formula. So you have to really think of left and right. That's why I taught you that way. When there's no piecewise, I can kind of do it simultaneously. Is everybody comfortable? Okay. Next key thing. If you take -4 plus 4 What do you get exactly? Say it.
0.
Good. This is going to become 0 divided by 0. We don't know what that is. We say undefined. Undefined is a fancy way of saying, I don't know. Okay? Really? That's what it means. We don't know what it is. We just don't want to admit we don't know, so we say, oh, think of a new word, undefined. So 0 divided by 0, we don't know what that is. But that's only when you plug in exactly 4. Okay? If you plug in exactly 4, we don't know what we get. But we're not plugging in exactly 4. We're plugging in close to 4. So watch this. If you plug in close to -4 plus 4, you're going to get a number. It'll be really small, but it's a number. And it will be the exact same number on the top as you get on the bottom. So say it together as a class. What do you always get if you take something divided by itself? 1. So if x is getting close to -4, either a little more or a little less, like we're doing the limit, this will equal 1. That's the whole reason we factored, was to find that. It's not easy to see that up here. It's very difficult to see. So be with me. Awesome. So now we can say, hey, if x is getting close to -4, this is 1. This is really close to -9, therefore the limit is -9. Now that's not a horizontal asymptote because we didn't find the limit as x approaches infinity. We're just analyzing the continuity of the function. Okay, pause for 1 second. We only have 1 minute to go. Look at me. Okay, what happened today doesn't happen a lot, but it does happen. My plan was to have you do this as homework, but I hate getting to a point in the discussion where it just doesn't feel complete. So you don't need to do any of this yet. Like I know I told you homework every night, and my goal is to get you homework every night, but my bigger goal is to get you to pass the test. Okay? And understanding is the key. So you do not have to do this tonight. You can wait. If you want to try some of them based on what we learned, you can do that. But just don't get frustrated. Like, hey, wait, something funny's happening, just wait. You know what I mean? Just move on. And then we'll pick this up again on Monday. Got it, guys.
What's our statement for this question?
Say again.
What's our statement for this question?
We didn't really finish it because the bell was approaching. But what we found so far, Caleb, is that I'm going to finish so I can finish my video. The left-right limits are going to equal -9. Therefore, the overall limit is going to equal -9. The last thing to do is to do this, like you did on the buff packet. Write down, well, what happens if you plug in exactly -4? For those that are still here, who can remember, we just said it a minute ago, undefined. So Lincoln, from your work on the buff packet, if you find the left-right limits, therefore the overall limit to all be equal to -9, but the function is undefined at x equals 4, is the function continuous?
No.
Has a removable discontinuity. And that's the conclusion. So there's the answer right there. Well, really, we have a little more time.
Are we just doing this packet for homework?
So you don't have to do this packet yet because we didn't have enough time to really talk as much as I wanted. If you want to try some, you can, but we'll talk about it again on, we'll probably merge into the next packet as well.
All right.
So right here, let's back up a little bit, Liza. Ms. Liza. Sorry for just. You started with this formula, right?
Yes.
That's a formula for finding the white order of the function f. Is that blue formula the same or different than this formula I'm now boxing in black? Those are the same. When we were finding the limit as x approached infinity, they were different. But they were good enough for an infinite limit.
Right.
In this case, they're identical. And then this one's identical too. Good with that? So they're all the same formula. But it's easier for me to understand what happens using this formula. The very last one. Because I can say, okay, if I plug in an x that is almost -4, what's this going to equal? 1. What's this going to equal? Close. Won't be exact, it's going to be very close to -9. That means the limit is -9. Good with that? Perfect. Okay, so I know the left-hand limit, the right-hand limit, and the overall limit are all -9. I need to find the function's value. Like what's happening precisely at x equal -9. So I just go back to the formula right here. And now I plug in not close to -4.
Oh, but exactly -4, and then, yeah,
Got it?
Yes.
So then this part becomes undefined, which means we don't know.
right,
So kind of a funny question, like what's -9 times I don't know?
right.
I don't know.
Okay, yeah,
Better?
that makes sense.
Good job.
I have a quick question about this is going to be done, but removable discontinuity and a jump, what's the difference?
What is
So let's look at that real quick.
I just can't remember.
Oh, you're good. So this graph is going to look like this, Clark. Let's go here. So this is a picture of that formula, the XY pairs.
Yeah.
And when we get to this XY pair right here,
If it doesn't,
where
I'm gonna
x
pause
is
it.
equal to -4, there is no y coordinate.
Pause it.
Just the dollars.
Right, because we can't fill it in because we don't know what the y is. It's undefined. All the other XY pairs are there. So it's not a jump. A jump is more where you have a
Where
function.
there's like,
It's steps.
Yeah.
Yeah, you saw it on the last packet. Does that help a little
yep,
bit?
100%. Thank you.
You're welcome.